Welcome to the second part of the CKA Top 10 Sure Shot questions. I am very happy to receive a good response from students for the first part. This is the second video in the series. If anyone is coming here without watching part 1, I highly recommend watching it first, link in the description. In this video, we will cover the next 5 questions in the CKA exam. The 6th question is related to persistent volume and persistent volume claim. This is one of the sure shot questions with high weightage marks. Without delay, let's move on to the question. The 6th question is: create a new persistent volume named WebPV. It should have a capacity of 2 gigabits, access mode should be read-write once, host path/vol/data and no storage class name defined. Next, create a new persistent volume claim in namespace production named WebPVC. It should request 2 gigabits storage, access mode should be read-write once and should not define a storage class name. The PVC should bound to the PV correctly. Finally, create a new deployment, WebDeploy in namespace production which mounts that volume at /tmp/webdata. The pods of that deployment should be of image Nginx 1.14.2. We can see the question has 3 parts. First, we need to create a persistent volume, then we need to create a persistent volume claim. Finally, we have to mount volume to a Nginx deployment. First, go to the documentation. Search for PV, and choose the second link, because the second link is the correct one for solving this question. Choose this YAML file as reference. According to the question, we need to change the persistent volume name as WebPV. Storage class is not mentioned in the question, so we can remove that. Change the capacity to 2 gigabytes. And host storage path should be /vol/data. Let's apply the YAML file. Okay, persistent volume is created, so we completed the first part of the question. Let's check the available namespace. Okay, we need to create production namespace. Next, we need to create a persistent volume claim. Choose this YAML file as PVC reference. Let's modify as per the question. Claim name should be WebPVC. Namespace should be production. We don't need storage class. And storage should be 2 GB. Let's apply the YAML file. Okay, WebPVC is created. We have completed our second part of the question also. Go to the documentation for deployments. Click on the first link. Choose this YAML file as a reference. Change the deployment name as WebDeploy. Add production namespace. In this deployment, we need to mount the volumes as per the question, so go to the documentation again. You can see a sample reference YAML file for mounting the volume. Copy the volume part and paste it under the spec. Change the claim name to WebPVC. Copy the volume mount part and paste it under the containers section. Change the mount path to /temp/webdata. Save and exit. Let's deploy. Oh, some error was found on the 20th line. Let's check. Okay, we missed mentioning volume in the spec section. Let's deploy again. Yes, deployment is successful. Let's wait for some time to run all pods. Yes, pods are running. Let's check whether PVC is bonded or not. Yes, PVC is bonded. Finally, we solved the question. Okay, the next question is related to exposing a pod through node port. It is a tricky question because it is not easy to expose a pod through a specific node port using imperative commands. But don't worry, we will cover the same question here. Okay, let's move on to the next question. The seventh question is, to expose the existing pod called Nginx pod service name as node port service. This service should access through the node port. The port number is 30,200. The weightage of this question is 6%. It is a little bit tricky question. You can see, the Nginx pod is running in the cluster. We have to expose this pod through node port. Let's expose it through node port. The command is kubectl expose pod, the pod name is Nginx pod, and the service name is Nginx node port svc. And the service type is node port. It's important to note that the port flag in this context refers to the container port within the pod, not the port on the host machine. Okay, service is created. Let's check the service. Okay, you can see the service is exposed to a random port. According to the question, it should be exposed through port 30200. In order to do that, we need to edit the service. The command is kubectl edit service, and the service name. Here you can see the service is running in port 31249. Just edit, and then replace it with 30,200. Let's save and exit. It will automatically redeploy. You can see now the service is exposed through port 30200. Okay, let's try to access the service through node port. In order to access the service, we need to find the node IP address first. Okay, you can see node 1 IP address is 172.30.2.2. Let's copy it and curl that IP with the port 30200. Yes, as expected, this service is exposed through node port. Okay, we have successfully completed this question. Some more questions you can find in my existing CKA certification series. I will add links in the description. The next question is from Daemon Sets. This is also a sure shot question with high weightage. Okay, let's go to the question. The 8th question is, use namespace project 1 for the following. Create a daemon set named daemonimp, with image httpd alpine and labels id equals daemonimp, and with this UUID. The pods it creates should request 20 millicore CPU and 20 MB memory. The pods of that daemon set should run on all nodes, also control planes. Let's check the available node. We have 2 nodes, one master and one worker node. We are going to create a daemon set for this cluster. A daemon set is a type of workload object that ensures that a specified pod runs on each node within a cluster. It's particularly useful for monitoring agents, log collectors, or other system-level utilities. Go to the documentation and search for the daemon set. Copy this YAML file up to the volume mount. Paste into a YAML file. Just modify as per the question. Name should be Daemon Imp. Namespace should be Project 1. Labels should be ID equals Daemon Imp. And copy the UUID also. Just replace the equal symbol to colon. We can remove other labels. Mentions the same labels under the match labels. Image should be HTTPD. Container name is not mentioned in the question, so we can give any name. We don't need the limits. CPU request should be 20 millicore and memory is 20 MB. Okay, Project 1 namespace is not available, so we have to create this first. Okay, let's apply the YAML file. Daemon set is created. Let's list the daemon set. You can see, 2 pods are deployed in this cluster. Let's see in detail. We can see 2 pods are deployed, one in the worker node and another in the master node. Okay, we have successfully completed our task. Okay. Next up are questions from network policy. Actually, We can't specify a particular question for network policy because it is a wide-ranging topic, and they can ask any type of question. I've mentioned a common question from network policy here, but don't worry. If you go through my CKA series, you can find more network-related questions. I will include the link in the description. Additionally, I am planning to create a series exclusively for network policy with 10 questions because, in my experience, network policies are the most challenging part of this certification. Okay, without further delay, let's move on to the question. The 9th question is: you have a Kubernetes cluster and running pods in multiple namespaces. The security team has mandated that the DB pods on the Project A namespace be only accessible from the service pods that are running in the Project B namespace. This is a little bit difficult question. I will explain the question with a diagram. As per the question, you may have more than 2 namespaces in the cluster. In this diagram, you can see 3 namespaces, Project A, B, and C. By default, all pods in all namespaces can communicate with each other. As per the question, we have to only allow ingress connection from the service pods of the Project B to DB pods of Project A. So we need to block other pods of Project B as well as other namespaces. Let's go to the cluster. Let's check the namespace first. We can see 3 namespaces. Next, we need to find the pods of all namespaces. Project A has 1 DB pod, Project B has 2 pods, Service and Web, and Project C has 1 pod, Application. This is the IP address of DB pod. First, we need to check the connectivity using the ping command. We can see the service pod can communicate with DB pod. Let's check other pods' connectivity. Okay, the web pod has connectivity to DB pod. Okay, application pod also has connectivity to the DB pod. According to the question, we can only allow the connection from the service pod of Project B, and the rest of all namespaces and the pod need to block. We need the help of documentation to solve this scenario. Go to the network policies. Copy the YAML file. Copy the YAML file. Save and exit. Before editing, we need to add some labels on namespaces. In order to implement network policies in this scenario, we need to label the namespace first. We added one label in the Project A namespace, and we need to do the same in Project B namespace. Next, we need to find the labels of the pods in the Project A and the Project B. Please note this all labels, because network policy is working based on the labels on the pods. Let's edit the YAML file. First, edit the namespace. It should be Project A, because we are applying this policy on Project A namespace. Match label should be the label of DB pod. We don't need egress. We don't need IP block. Namespace match label should be the labels of Project B, because we need only the ingress connection from Project B. Pod selector should be the label of the service pod, because we need the connection from the service pod to DB pod. Two conditions are there, and OR condition. You can see, now the settings are in OR condition. Which means, any one of the conditions is true, then the policy will allow the connection. So we need to remove the dash in front of the pod selector in order to make the condition as AND. Which means, the policy will only allow the connection when both conditions are true. Let's save and exit. Okay, we have applied the policy. Let's check the connectivity now. First, we are trying from the service pod. Okay, connection is there. Now we are going to try from the web pod. You can see, connectivity is blocked by network policy. Next, we can try from the application pod. Yes, that also is blocked by the network policy. We have successfully completed this question. And I will show you one more thing. I will show you what will happen if we are not remove the dash from the YAML file. Let's see. Let's delete the existing policy. Now I am going to show you how will behave the policy if we added the dash. Now it becomes an OR condition. That means, either one condition is true, then it will allow the ingress. Apply again. Application pod is blocked. Service pod is allowing. Web pod is also allowing because the network policy is checking whether it is coming from namespace project B or service. Either one condition is true, then it will allow the ingress. In this case, web pods is from namespace B, so the policy will allow the connection. Next question is from roles and role binding. You can expect a question from this area. The final question is, create a new service account GitOps in namespace project 1. Create a role and role binding, both named GitOps role and GitOps role binding as well. These should allow the new service account to only create secrets and config maps in that namespace. I will explain the solution of this question with a diagram. We have a namespace project 1. We have to create a service account called GitOps. Then we need to create a role that should only allow creating the secrets and the config map on the namespace project 1. Then we need to create a role binding, and we need to bind the service account to the role. So by using the service account, we can create only the secrets and the config map in the project 1 namespace. Let's list the available namespaces. Okay, project 1 is there. Let's create the service account first. Now we have created the service account in the project 1 namespace. Next, we need to create the role. Let's take the help. We need to find the verb and resources in the help page. Take this sample as a reference. Verb should be create. Resource should be secrets and the config map. Role is created. Let's describe the role in more details. Perfect. We can see by using this role we can create config map and secrets. Now we have completed the service account and role. Next we need to create the role binding for connecting this service account with the role. We can take the help here. Take this as a reference. Role should be GitOps role. Here we need to mention our namespace project 1. Here should be the service account name GitOps. Perfect. Role binding is created. Okay, we have created the role binding. Let's check whether the service account can create pods in the project 1 namespace. The answer is no, because GitOps service account doesn't have permission for creating the pod in the project 1 namespace. Let's try for the config map. The answer is yes. Let's check for the secrets. The answer is yes. Let's try for the deployments. The answer is no, which means our role and the role binding is perfect. GitOps service account has the permission only to create secrets and config map in the project 1 namespace. Congratulations! We have successfully completed 10 SureShot questions. However, you may be surprised that I haven't included any questions related to deployments here. That's right, I did not include any deployment questions because deployments are straightforward, and everyone knows how to deploy a pod, and how to scale the pods. Which is why I couldn't add deployment questions in the top 10. Are these 10 questions enough to pass the CKA exam? No, these 10 questions are not sufficient for passing the CKA exam. You will get only just more than 55%, but that will help you pass the exam if you cover some more topics. These topics include deployment, taint and tolerations, horizontal pod autoscaler, config map, sidecar, event logs, ingress controller, and init container. Suppose I have planned this series for 20 questions, then, these will be the next questions in the series. But don't worry, you can find this question and its answers in my existing CKA series. Why didn't I add the above topics in this video? Because I sorted these questions based on the weightage of each questions. So, most probably they will ask the question from above topics for below 5% weightages. Please note that we covered 10 SureShot questions in this video, and the chances of these 10 questions appearing in the exam may vary in the future. Thank you, happy learning.